Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have x plus 8 whole square equals to 64, and we solve this problem for all the values of x. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And at last we will be verify that which of the roots are solution and which of the roots are extraneous root. And now we move towards the solution of this problem from first method. And in the first method, we apply here the nice algebraic formula into the left hand side, and you know about that. If we have a plus b whole square equals to a square plus 2 times of ab plus b square. So according to this nice algebraic formula, we just write here the above equation as in this form. Here we have this is x plus 8 square equals to x square plus 2 times of x into 8 plus 8 square, and this whole equation is equals to 64. And now further in the next step we need a more simplifications here, and we rewrite this equation as x square plus this is 2 times 8 becomes 16x plus this 8 square equals to 64, and we move the term 64 from right hand side to the left hand side, and it will becomes minus 64, and this whole equation is equals to 0. And now further in the next step here we need to add or subtract the like terms, and we have this is minus 64, this is plus 64 are cancelled out by each other, and we get the remaining values are from here we get x square plus 16x, and this whole equation is equals to 0. And now in the next step here we need more simplifications, and this will be written as here we take common x from both of these two terms, and we get the remaining values are from here we get x plus from here we get 16, and this whole equation is equal to 0. And now we divide this equation into the two cases. The first case is we write x is equals to 0, and the second case is we write x plus 16 is equals to 0. So this is the first root of the given equation, and from here we move plus 16 to the right hand side, and we get our x is equals to minus 16. So you see that in the first method we get these are the two roots of the given equation, and now in the next steps we need to verify that is these roots be the solution or is these roots be the extraneous root. So for verification of this we need to copy down given question statement. Here it is x plus 8 whole square equals to 64, and now in this side we will be verify x is equals to 0, and in this side we will be verify x is equals to minus 16. So we verify both of these two values, and now here first we just verify x is equals to 0. So for this we substitute x is equals to 0 into the left hand side, and we check its behavior. So when we put it here it will becomes 0 plus 8 whole square is equals to 64. And now we check that is both of the sides are equal or not. So we have 0 plus 8 becomes 8 square equals to 64, and we easily get here 64 equals to 64. So you see that the value of x is equals to 0 is satisfied our given question statement. And now in the same pattern we verify the second value of x, and that is equals to minus 16. So we put x is equals to minus 16 into the left hand side, and it will becomes minus 16 plus 8 whole square is equals to 64. So in the next step we need more simplification to verify the value of x. So minus 16 plus 8 becomes minus 8 square is equals to 64. So minus 8 square becomes, you know that when we take the square of negative term it will always gives us the positive answer. So we get the square of 8 becomes 64 equals to 64. So this means that again both of the sides are equal. So if again both of the sides are equal, this concludes about that the second value of x is also satisfied our given question statement. And finally we have the solution set of the given question is x is equals to 0 and minus 16. So these are the two values of x, and this is our final answer which we get here from first method. And now we again solve this problem. And now in the next step we again solve this problem for second method. So for second method we need to copy down given question statement here, and the given question statement is x plus 8 whole square is equals to 64. So here we again solve this problem for second method, and here we use another different approach to solve this problem for the values of x. So here we just use the radical technique to solve this problem, and we will apply here the square root on both of the sides. So when we apply square root, so this term is written as in this form. We have square root of x plus 8 whole square is equals to square root of 64. And now you see that this 2 and this square root are cancelled out by each other, and we get here x plus 8 is equals to, this is 64, and we know that square root of 64 becomes here 8. And further you know about that when we apply square root on both of the sides, we will be right here plus minus sign on any one of the sides. So now here we break this value in two cases. Here we write the positive value, it is x plus 8 is equals to plus 8, and in this side we will be right here the negative value, it is x plus 8 equals to minus 8. And now here we need to focus on both of these two cases, but for here we move plus 8 to the right hand side, and we get x is equals to 8 minus 8, and here we easily get the value of x is equals to 0. So you see that in the second method we again get the first root of the given equation is x is equals to 0. And now in the same pattern we move this plus 8 to the right hand side, and we get minus 8, and this is positive 8 is also becomes a negative 8, and we easily get the value of x is equals to minus 8 becomes here minus 16. So this is the second value of x. So now you see here from both of these two methods we will get two values of x, that is 0 and minus 16. But in the first method we already verified that this value of x is satisfied our given question statement. So finally we have the solution set of the given question is 0 and minus 16. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.